Hello everyone. So today we are going to see the iterative approach for printing all longest common subsequences. So in the last video we learned the length. Okay, we have to find the length of LCS. So we did longest common subsequence, but we find the length. What is the length of that longest common subsequence? Now today we are going to see printing of the print LCS, all longest common subsequence. Now we have seen that there are so many, but the longest length we print. Okay, if there are multiple with four lengths, we print. Now we need to print all strings. Okay, we need to print all strings with longest common subsequences. Okay, now so for this we need iterative approach. Now why iterative approach? Because recursive approach does what? Recursive approach do not store your length at each point. What we used to do is we have one I which is for string s, let's say, okay, which is something a b c d b a, okay, and then we have j which is for string t, which is nothing but b c a d e, okay, and the longest common subsequence here is b c D or BCA. Okay, BCD or BCA. So it's three length. Okay, so your answer should be three, which is the three length longest common subsequence. Now, what you do is when you are at I0 or J0 and you start, and what you check is this matching. If it's matching, you do 1 plus and you either go I plus 1j or maximum of this two, which is I plus 1j or ij plus 1, that we did last time. Okay, but if these are not matching, I'll try this combination or I'll try this combination to match. So I'll remove this, I start from this, or I remove this a and I start this string from here and this whole string. Okay, that's what we used to do. So we are not storing at every point. So your dpij is stored, but it's stored for some of the values only where you find it matching. You'll not find it everywhere where it is not matching also, like from bcdba and from cade. What is the length, maximum length you get? So you'll not get it here. Okay, so for that we need the table, proper table. Now let's say if I make this table of size n cross m, wherein is s size and m is t's size, t string size, and then we calculate a table, it's proper um, with the sizes or lengths allocated at each point. Okay, now what we used to do is, let's say we have this table, and let me take one small string example. If I have, so let this be triple A. Very small example of, let's say, S is triple A and T is double A. Okay, so we have 3 cross 2. So we have 3 rows now. 1, 2, 3, and 2 columns. Okay, 1 and 2. It's bigger, but it's okay. So we have 3 rows. Okay, so this is for S. Okay, where I is for S. Okay, and we have 2 columns. So this is for T. Okay, now uh, what I'll do is, okay, I'll make it 4 4 4 and 3. Okay, so I consider 0 I0 and J0 as nothing, both are empty. So initially I'll put, if I is 0 or J is 0, that means I have LCS 0, length is 0. Okay, now this is I is equal to 1, I2 and I3. This is J1 and J2. Now what we'll do, for I is equal to 1, for J is equal to 1, we'll do 1 index minus. That means we'll compare Si minus 1 and Tj minus 1, because that are 0 based. But for this purpose, we put it 1 based to fit in the box so that I can refer for the above ones. Okay, I need the above ones, that I'll tell you later. Okay, so let's say we compare this two. That means I compare this A with this A. Okay, and it is matching. Then what I'll do? I'll do 1. There, 1 plus, what I will do? 1 plus whatever is matching until the last point. So whatever is here until I minus 1, j minus 1. So I'll do 1 plus 0. Which 0? This 0. Okay. Okay. And if it is not matching, let's say if this is B, okay, that means it is not matching with the A. Or consider your T as AB instead of AA. Okay, consider this as AB. Okay, so now we move forward. We move for S is equal to. Okay, so now our first loop is I, which is running from 1 to 3, and then is J, which is running from 1 to 2. Okay, so 1 1 matched. Now we have 1 2. So is A is equal to B. So for 1 2. Okay, this A is not equal to this B. So what we'll do? This A is not equal to this B. That means we could either take maximum of this or this, okay, of above or below. Now, what does this mean? This is mean that maximum of, if it is not matching, we'll take maximum of I minus 1j, ij minus 1. Okay, so I minus 1j is 0, 2, ij minus 1 is 1, 1. If we are currently at 1 2, okay, then it should be 0 2 or 1 1. I hope you got. That's what we used to do in the recursive approach, right? But it's easy to understand there. It's difficult to understand here. Okay, and for this reason we put one extra row and column. Okay, so this is 0 and 1, so what we'll put here? 1. That means if I take a only A from here and AB from here, I still has LCS as 1, length as 1. Okay. Okay. Now we reach at 2, 1. So for 2, 1, here this is A, this is A. Again, it is matching and we have to do plus 1 from here. So this is 1. Okay. Now for this thing, this is A, this is B. Again, it's not matching. So we'll do maximum of this 2. Okay. Maximum of this 2 will be again 1. So if I take AA and AB, then also it's 1. Cool. And same case for 3. If I take this A fix now with this A, it's 1. With this, it's 1. So that means only one LCS I get. Now, how to find what is your longest common subsequence? So now, let's remove this. Like, we are not printing all the strings with the LCS. Again, that will need a backtrack approach, recursive and backtracking approach. Because to maintain all this is, again, we need recursive approach and no need of DP there. But let's say only once. So this is your common approach. Okay, your common approach which you will apply backtracking approach, and it has a very less constraints of around 50 or something. Okay, because you need to traverse each string and you need to put all of this which are longest common subsequences. Okay, so if si is equal to tj and you reach at the end and you find the same string from both the points, that means you are doing. But all strings, we forget that it's all strings. Let's just print one LCS. Print any one longest common subsequence. Okay, it could be anything, but it should be of length 3 or any LCS which you got. So from this table, what you'll do? So let's say you get this table. I'll make it clearly. Okay, and you got it 0, 0, 0, 0, 0, 0, and 1, 1, 1, 1, 1, 1. Or 1, 0, sorry, here. No, 1, 1, 1, 1, 1, 1. Everywhere it's 1. Okay, this is 1 only. Cool. Okay, so we'll start from this end now. We build it like from forward to backward. We'll make the string from backward to forward. Now what we'll do? We'll start from I is equal to n minus 1 and j is equal to m minus 1. So in this DP state, it's I is equal to n and j is equal to m. Okay, but while comparing, we'll do I minus 1, j minus 1. So we got 1 here. Now what we'll check? If s of I minus 1 is equal to t of j minus 1. And that means this character is valid. It's this is the character of longest common subsequence. So we'll put it in my answer. So I'll put answer dot push back this si minus 1 where it is matching. Now for matching characters, we put it here and we will go where? We'll go on cross direction. We'll go in cross direction because that character has been made from the crosswords. Okay, from the crosswords. So we'll go in the cross direction if this is matching. So let's say our string is AAA and AB. We got A and B. Is A and B matching? No, it's not matching. So we'll not grow crossword. We'll go on whichever side is more valuable. if it's this one or this one, whichever is more bigger. Now here both are bigger, so you choose to go on any side you want. Okay, any side you go, you'll get the answer. That means that. So let's say if I chose to go upwards, so I'll do my I minus minus. So now my I is initially, this I is uh, 3 and my j is 2. Now my I has become 2. Okay, again I'll compare what? S of 2 minus 1 is equal to T of 2 minus 1. So I'll compare this A. Okay, let me change the color. I'll compare this A with this B. Is this A and this B matching? No, it's not matching. So what I'll do? This is also not matching, right? So what I'll do? I'll either go upwards or the rightwards, because I have to go from the maximum of this two, because I have put the maximum of this two over here. But as both are same, you can go in any direction. Now let's say I try to choose to go in the j direction. So now my j has become 1 now. So again, you compare s of 2 is 2, 2 minus 1, to j became 1 minus 1. So you compare s of 1 with t of 0. S of 1 is a and t of 0 is a. This is matching. That means you will push back this a into your answer string. Cool? We'll push back this a into my answer string. And now as this is matching, I'll go on diagonally upward direction, not maximum of this two. I'll go diagonally up, which is 0. So once it has 0, I'll return or I'll quit the loop. I'll come out of my while loop. Okay? Or if I won't, this becomes 0. So now my I is what? I is 0, j is 0. We have to do this until I greater than equal to 0, j greater than equal to 0. That's it. Cool? So you got your answer. Now let's take one bigger example for you to understand. Okay? Let me take the example. We won't have Leetcode problem for this, so I will be doing example over here for you to understand. ABCD, there are so many other platforms. I'll paste the link in the description. You can go and do out there. And T is BC, let it be BD, GE, okay, so we'll first make the table. Let the table be of different color. Okay, so your table is of 5 cross 5. Okay, so actually it has to be for 6 cross 6. Sorry, 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. I'll put the zeros. Okay, now for filling, we'll start from this A, this B. Is A and B matching? No. So it should be 0. It should be diagonal plus. If it is matching, it should be plus or maximum. Again, this A and D matching? No. AG matching, AE matching, AK matching, nothing is matching. So this all will be 0. Okay, this is my S string, which goes over here, and this is my T string, which goes over here. So this is A, B, C, D, E, and this is B, D, G, E. Okay, we have used one extra row and column just to have that minus while taking maximum. It shouldn't create problem. Cool. Now we are at this position. Okay, at B position. Cool. Now we'll compare this B with this B, and it's same. Okay, so we'll do diagonal plus 1, which is 1. Okay. Now I'll compare this B with D. It's not matching, so I'll take maximum of this two, which is 1. B with G, not matching. This two, maximum 1. This and this, okay? I hope you're getting. B with E, again not matching, 1, 1. Why 1? Because this and this I'm comparing. Maximum of this two. Cool. Now we are at C. Okay, C with B, no, not matching, but maximum of this two will be 1. C and D not matching, but maximum of this two will be 1. C and G not matching, but maximum will be 1. CE not matching, but 1, 1. Okay. Now D. D with B not matching, but maximum of this two will be 1. D with D matching, so this 1 plus 1 because it's matching, so this became 2 now. Okay. Again, this will be all 2 now because maximum of upper and left one. And for E, it will be 1. this 2, and 2 is matching at which point? At here. Okay, so 1 plus this 2 will, this will be 3 and this will be 3. So we got this table. Now what we will do? Now let me take a different color. Now we'll start from this point, okay, and I'll compare. Okay, so here this is E, this is K. Is E and K matching? No, not matching. So I'll go from maximum of this two. So I'll go in this direction. Okay, now I came to this point. This E matching. So in my answer, I'll push back E. So this is my answer which I'm making. Okay, just remember this. Cool. Now, as this is matching, I'll directly go to the diagonal direction, which is here. Again, this D, this is G. Okay, this is D and this is G. It's not matching. So I'll go from maximum from this two. So I came here in this direction. Again, this is D, this is D. It's matching. So I'll push back and I'll go in the diagonal direction, which is here. Okay, so this is C and this is B, not matching. So I'll go maximum. So I'll go upwards maximum. This is B and this is P, it's matching. So I'll put the B over here and I'll go in the diagonal direction. Okay, when I reach to the diagonal direction, my J becomes 0 and I also become 0. I'll go out of the loop. Cool. So your string became EDB, but actually it's reverse. So it's BDE. It became EDB, but actually it's BDE. So if you compare, the longest common subsequence is BDE, BD, BDE with the length of 3. Clear? So this is your iterative approach and this could be used in many problems once you understand how to field DP table. And then once the way you have filled it, you just have to use it in the reverse way to get your answer. Okay, so now in the next video, we'll try to do some problems which is again related to the strings and little bit hard. So stay tuned for the next video. Do like, share and subscribe.